Hi students, how is your preparation for JEE Mains? The thumbnail of this video is what to do before 1 week of JEE Mains exam. But the students, those who are appearing on 22nd January, only 3 days time is there. See here, 3 days or more than 3 days. The first thing, don't panic about this JEE Main exam. It is a basic entry level concept test exam. More than 60% of the questions are direct formula substitution and concept based questions. Okay, this is the first thing. Second one, don't go for any grand test or mock test. For these 3 or 4 days, don't write any mock test or grand test. And third one, before going to exam, at least you have to revise 2 or 3 times the total formulas and concepts of all three subjects. This is very important one. And the students, those who are appearing on 28th or 29th, for that students, more than 1 week time is there. But that students, you have to note down the important chapters and subtopics. On that subtopics, you have to practice PYQs. For example, if you take any concept or any subtopic, on subtopic you have to practice the PYQ. If if you are trying the PYQ, it is not getting the answer, then do the solution and don't waste the time. Okay, first thing here, from all the subjects, physics, chemistry, and maths, first of all, list out the important more weightage chapters under that subtopics. For the chapters and subtopics, you have to revise the formulas from your short notes, or if short notes is not there, and revise from your class notes. In this video, I'm going to list the important or more weightage chapters and subtopics from first and second year. So here, these are the topics from class 11. First one is units and dimensions, kinematics, work power energy, system of particles, gravitation, mechanical properties of solids and fluids, heat and thermodynamics, and waves and oscillations. So here, units and dimensions and kinematics. Kinematics means motion in one dimensional and motion in two dimensional. At least we can expect two questions from these two chapters. And work power energy, system of particles, and gravitation, two questions. Mechanical properties of solids and fluids, one or two. Heat and thermodynamics, two. And waves and oscillations, one. So total 2 plus 2, 4, 6, 8, 9. Means around 10 questions from these chapters. These are the important chapters from class 11. Okay, under these chapters, what are the subtopics you have to concentrate more and concentrate more on the formulas and concepts. See, first one, units and dimensions. Here, dimensional formula. So, very important dimensional formula for the question may be like this: which of the following options are same dimensions? Which of the following are dimensionless? For this dimensional formula, don't buy the diamond formulas. You have to derive the dimensional formula from the formulae. For example, gravitational universal gravitational constant. The force between attraction force between two masses F is equal to G into m1 m2 by v square. F is force dimensional formula is m L T to the power of minus 2, mass m into m square, distance r square. From that formula we can derive capital G. Like that, all the dimensional formulas you have to derive only from formulas, not by that one. Next one, conversion of units. See, a conversion of units means one system of units into new system of units. That is n1 u1 is equal to n2 u2. Next, the third one, deriving the relation between physical quantities. This is also very important. Principle of homogeneity. So very important. Principle of homogeneity means for a physical quantity, the same physical quantity can be added or subtracted. So here, for same physical quantity, we have to add or subtract from the same physical quantity. This is the principle of homogeneity. Next one, percentage of error, error calculation. Next one is vernier calipers and screw gauge. In each vernier calipers and screw gauge, we have to find out the least count. In vernier calipers, for least count, there are three formulas. And screw gauge, first we have to find out the pitch. After that, least count. Maybe in screw gauge, there is a positive error and a negative error. These are the important subtopics from units and dimensions. Next one, kinematics, one dimensional motion. Calculation of average velocity and average speed. See, in last year, see most of the problems, most of the papers, what is the average velocity to cover equal distance and equal intervals of time? So direct formula based things. Your calculation of average speed and average velocity, uniformly accelerated motion. There are equations of motion. V is equal to u plus at. S is equal to ut plus half at. So like that, there are four different equations. And motion under gravity, freely falling body, vertically projected body. If a body is dropped from a height, what is the time taken to reach the ground? What is the velocity while it is reaching the ground? What is the distance traveled in successive seconds? And graphs. This is in one dimensional motion. In two dimensional motion, say trajectory equation. For example, two equations are given. For x is equal to x is in terms of time and y also in terms of time. We have to eliminate the time, then we have to derive the relation between x and y. Trajectory equation is very important one. Vectors, projectile motions, very important. Projectile motion here, maximum height, time of flight, range, equation of trajectory, y is equal to ax minus bx square. If a and b are given, from that a and b, what is maximum height, time of flight, range, and relation between maximum height and range, horizontal projectile. This is projectile motion. And relative motion, riverboat problems, rain umbrella problems, and circular motion. This is under two dimensional. Next one, work power energy. Work power energy, work done by constant force, work done by variable force, fx graph, work done from the graph fx graph, energy, kinetic energy and potential energy. Say kinetic energy is equal to p square by 2m. When kinetic energy is constant, if mass is doubled, what is the percentage change in momentum? Like that, and potential energy, conservative field and a non-conservative field, potential energy of a spring, like that. Next one is work energy theorem and the law of conservation of mechanical energy and power, vertical circular motion and collisions. These are the subtopics from work power energy. Next one, system of particles. Generally, most of the students are neglecting system of particles. See here, if you observe last year papers, maximum problems are formula based. If you know the moment of inertia of different particles and center of mass, velocity of center of mass, acceleration of center of mass, from a sphere, another hole is made. What is the shift in center of mass? Like that, very basic level. Center of mass, kinematics of rotational motion. Kinematics of rotational motion means, for example, in linear motion, v is equal to u plus at. In a rotator motion, omega is equal to omega naught plus alpha into t. These are kinematics of rotational motion. And the torque and equilibrium of a rigid body, movement of inertia of a different symmetric bodies, and angular momentum and conservation of angular momentum, very important. I1 omega 1 is equal to I2 omega 2. And rolling motion, if a body is rolling on a surface, on a horizontal surface and inclined surface. On horizontal surface, what is rotational kinetic energy, translational kinetic energy, total kinetic energy. And on rolling motion on an inclined plane without slipping, velocity, acceleration. These are only formula based questions we can expect from this chapter, but most of the students are neglecting system of particles. Next one is gravitation. It is also easy chapter. And universal law of gravitation, gravitational field strength, acceleration due to gravity, and the variation of g with latitude, altitude, and rotation of the earth. Next, gravitational potential and potential energy, orbital velocity and escape velocity, energy of a satellite, and Kepler's law. So here from gravitation, for example, one body is at a certain height from the surface of the earth. What is the work done to lift the body to another height? For this one, work done is equal to change in potential energy. If any satellite is revolving around an orbit, different orbits, if you want to shift from one orbit to another orbit, in that case, work done is equal to final total energy minus initial total energy. Kepler's laws, it's a very, very important law of areas, law of time period, and so in law of areas, areal velocity formula is very, very important. This is from gravitation. And the mechanical properties of solids and fluids. So Young's modulus, rigidity modulus, bulk modulus. So most of the problems, 90% of the problems are Young's modulus. If two wires are connected in series, what is the resultant Young's modulus? In parallel, like that, what is the elongation? Y is equal to F by A into delta L by L, and the braking stress and the braking force. See, your braking force does not depends on dimensions, only depends on nature of the material. Braking stress only depends on area, does not depends on length. Next, elongation due to its own weight. There are two formulas for this one, and elastic potential energy. And fluids, fluid statics and fluid dynamics. In fluid statics, fluid energy, when the fluid is at rest, what is the fluid pressure? If the fluid is if a fluid is in a container moving up, accelerating upwards, accelerating downwards, if the fluid is moving in horizontal with an acceleration a, like that. And fluid statics, very, very important. Bernoulli's theorem, equation of continuity, flux velocity, range, maximum range, same range, this one. And the viscosity is a very, very important. Only three formulas are there: Newton's formula, terminal velocity, and this is viscosity, and surface tension, also very, very important from fluids. Next one, heat and thermodynamics, expansion of solids. There are the different types of expansion: coefficient of linear expansion, areal expansion, volume expansion, alpha, beta, gamma. Alpha is to beta is to gamma is equal to 1 is to 2 is to 3. For isotropic solids, alpha, gamma is equal to 3 alpha. Anisotropic solids, gamma is equal to alpha x plus alpha y plus alpha z, like that. And another important thing from expansion of solids, thermal stress and thermal force. Next, calorimetry, it is also very, very important, but somewhat students are feel difficulty this calorimetry. Next, transmission of it is very, very important. Heat can be transferred in three different ways: conduction, convection, and radiation. So conduction is very, very important. Dq by dt is equal to Ka theta 1 minus theta 2 by L. This is heat current, thermal resistance, and this is about transmission of heat. Next, Stefan's law. Next, Wien's displacement law. Thermodynamics is a very, very important. First law of thermodynamics: dq is equal to du plus dw. Here, dq is a heat energy. It is a path function. And the internal energy, there are different formulas for internal energy. It is a state function. And work done also, path function dw is equal to pdv. Dw is equal to p into v2 minus p1. Pw is equal to pdv nr dt and rastam. Is first law of thermodynamics. See here, very, very important. While using the first law of thermodynamics, we have to consider the sign convention, and different thermodynamic process: isothermal process, adiabatic process, isochoric process, isobaric process. So very, very important. This is about thermodynamics. And the kinetic theory of gases. And kinetic theory of gases law, molar specific heat of gas, CP/Cv, in terms of degrees of freedom. Monoatomic gas के degrees of freedom F ఎంత, diatomic gas, polyatomic gas, and the different velocities of gas molecules: RMS velocity, average velocity, mean velocity, and mean free path is a very, very important one. Next one, oscillations and waves. Oscillations law, displacement of a wave when it is started from mean position, started from extreme position, velocity and maximum acceleration, energy, potential energy, kinetic energy, average potential energy, average kinetic energy. And if a particle is in simple harmonic motion, if frequency is n, what is the frequency of kinetic energy and potential energy? It may be double, like that. Time period of a loaded spring. So last year we can observe most of the question papers. One thing, time period when springs are connected in series, springs are connected in parallel, like that, and simple pendulum. This is about oscillations. So waves also very very important. Only formula based. So different forms of plane progressive wave. Y is equal to a sine omega t minus kx. If the equation is given that what is the wave velocity, what is the frequency, what is the wavelength, and the speed of transverse wave, principle of superposition, standing waves and modes of vibration. If it is vibrating with single loop, fundamental frequency n is equal to 1 by 2 L into square root of T by mu, mu A into rho and rastam, like that. Standing waves and modes of vibration. Next, sound waves and organ pipes, beats and Doppler effect. This is from oscillations and waves. This is about from class 11. Next one, class 12. So electrostatics, current electricity, moving charges and magnetism, induction, AC, dual nature, atom, nuclei, semiconductors, wave optics and electromagnetic waves. So here, if you observe last 4 to 5 years papers, more than 50% of the questions from second year only. Therefore, second year topics are very, very important, and these are the important chapters from second year. See, electrostatics 2, current electricity 2, moving charges and magnetism 2, induction AC 1, dual nature atom nuclei 2, semiconductors 1 or 2, wave optics 1, EM waves 1. So, here 6, 7, 9, 10, 12. It is around 12 from first year, 10. 12, so 22, and the remaining three, some of the chapters we left from that chapters also we have to uh, just concentrate only on formulas. This is from second year, and we can now we're going to see the subtopics from second year. So second year topics are very very important. So here electrostatics, Coulomb's law, intensity of electric field, electric dipole, flux and gas law, potential and potential energy, and capacitors. So Coulomb's law very very important. If what ratio the charge can be divided such that force between them is maximum, 1:1 ratio. For example, two spheres of charge, radius r1 and r2, if they are put in contact and separated, what is the force between, like that. And the Coulomb's law, intensity of electric field, intensity due to different bodies, uh, conducting solid sphere and a non-conducting solid sphere, halo sphere, inside, outside. Graphs are so very very important. Electric dipole, dipole moment, and intensity of electric field and axial line of a dipole and equatorial line of a dipole. Next one, what is the work done to rotate the dipole, interaction energy of the dipole, flux and Gauss law, and potential energy. Potential also due to different bodies, halosphere, conducting solid sphere, conducting non-conducting solid sphere, and capacitors. uh, Different types of capacitor, parallel plate capacitor. What is the intensity between the parallel plate capacitor? If it is filled with a dielectric constant, what is the intensity? What is the force between the plates of the parallel plate capacitor? And the series and parallel combination, and also dielectric inserted between when the battery connection is made. And in that case, if the dielectric is inserted, what is its potential, potential energy, capacity, charge? If the battery is disconnected, what is about a potential energy, potential, charge, capacity, like that. So electrostatics also very very important. Next one is current electricity. So current electricity, electric current, current density, drift speed, mobility, Ohm's law, temperature dependence of resistivity. Current electricity is very very important. So, so most of the problems related to relation between drift velocity and mobility, like that. And series and parallel combination of resistors. This is a very very important one. Electrical energy and power. So if the bulbs are connected in series, low wattage bulb glows brighter than high wattage bulb. If bulbs are connected in parallel, high wattage bulb glows brighter than low wattage bulb. Power, energy formulas. This is electrical energy and power. Next one, cells connected in series, parallel, and a combination of cells, mixed grouping. And what is a uh, current is maximum for cells are connected in parallel, and Kirchhoff laws, Wheatstone bridge and meter bridge. So from second year, most of very most weightage chapter is current electricity. Next one, moving charges and magnetism. Magnetic field due to current carrying conductor, infinite current carrying conductor, finite current carrying conductor. If the point is along the axis of the conductor and half of the circle, next like that, this is a magnetic field due to current carrying conductor. Direction also very very important. Ampere's law, solenoid, magnetic dipole moment of a current carrying coil, magnetic force, force acting on a current, magnetic force on a moving charge F is equal to BQV sin theta, motion of a charged particle in magnetic field, motion in combined electric and magnetic field. This is very very important one. Motion of a charged particle in magnetic field. If the charged particle is enter parallel to the magnetic field, then there is no force acting on that one. Therefore, it moves in a straight line. If perpendicular field, the circular path, radius of the circular path R is equal to mv by bq. Like that, there are different formulas. And magnetic force on a current carrying conductor, Bill sin theta. Torque acting on a current carrying conductor, moving coil galvanometer, conversion of galvanometer into voltmeter and ammeter. Next one, induction, magnetic flux, Faraday's laws, Lenz's law. And this one is very, very important. What is the direction of induced EMF? Direction of induced current and motional EMF E is equal to BVL. Self induction and mutual induction, very, very important. Self induction for current carrying coil, solenoid, and mutual induction for coaxial circular coils and coaxial solenoids. So these are all formula based one. Next, alternating current, RMS current, average current, AC through pure resistor, inductor, and capacitor. What is the phase difference between applied potential and current? And RC circuit, LR circuit, LC circuit, LCR circuit is very very important. In resonance condition, what is a minimum impedance? What is a power and resonant frequency? Power in AC circuit and transformer. This is under alternating current. Next, dual nature. Uh, this is a dual nature, atom, nuclei, and semiconductor. These are under modern physics. At least we can expect 3 to 4 questions from modern physics. These are purely formula based. Say properties of photon flux. Next, intensity, number of photons emitted per second. If the radiation is incident on a completely reflecting surface, completely absorbing surface, what is the radiation pressure, force exerting, and de Broglie wavelength, very, very important. Lambda is equal to h by p, lambda is equal to h by mv, like that. Next, photoelectric effect, only one equation, E is equal to incident energy, E is equal to maximum kinetic energy plus work function. E is equal to maximum kinetic energy half mv square, or E naught, work function h nu naught, or hc by lambda naught. And graphs between intensity and current, graphs between frequency and stopping potential, and graph between frequency and maximum kinetic energy. Next, atom alpha particle scattering. What is the distance of closest approach? Impact parameter. Drawbacks of alpha particle scattering. Bohr's model. So very very important one. Bohr's model lo. Next, radius of the nth orbit. Velocity in nth orbit. Energy and hydrogen spectrum. So very very important. In hydrogen spectrum, Lyman series, different series are there. In each series, what is the ratio between maximum wavelength and minimum wavelength? 1 by lambda is equal to rz square into 1 by n final square minus 1 by n initial square. This is from atom. Next, nucleus, property of the nucleus, nuclear size, nuclear radius, nuclear density, and mass defect and binding energy, very, very important. Mass defect and binding energy, and Q factor value. There are three formula for Q factor value. Nuclear fission and fusion, we can expect a theory based question. And semiconductors, so one of the most important chapter, semiconductors. P type semiconductor, N type semiconductor. Which type of doping is used for P type semiconductor, N type semiconductor, majority charge carriers and P type semiconductor, N type semiconductor, electrical conductivity of semiconductors, PN junction diode. If PN junction at the junction, what is the direction of intensity of electric field? What is the direction of diffusion current? What is the direction of drift current? Like that, and forward bias, reverse bias. In forward bias, charge carriers are moving towards the junction. Width of the depletion layer decreases. Reverse bias, charge carriers are moving away from the junction. Width of the depletion layer increases. Barrier potential increases. IV characteristics of a PN junction diode. In forward bias, reverse bias flow, there are two breakdowns: avalanche breakdown and GNR breakdown. And these are the very, very important photodiode, LED, solar cell, and logic gates. Next one, wave optics, Huygens principle. Different forms of wavefront: spherical wavefront, cylindrical wavefront. Spherical wavefront is due to point source, and cylindrical wavefront is due to line source. Next one, interference. Interference, there is a redistribution of energy takes place in the a region of superposition. What is the formula for resultant amplitude, resultant intensity, maximum intensity, minimum intensity, ratio to maximum to minimum, and YDSE, very, very important. Next, diffraction. What is the linear position of first minima, second minima, angular position, linear position of central maxima, angular position of central maxima, and polarization, Brewster's law, and Morley's law. So these are the important topics from wave optics. Another important one, EM waves. We can expect one from this EM waves, this Maxwell equations and displacement current. Nature of electromagnetic waves and characteristics and properties of electromagnetic waves. This is also very, very important. The properties of electromagnetic waves transfer the energy. This energy is equally divided by electric and magnetic fields, 1:1 ratio. Intensity of electromagnetic waves. Next, electromagnetic spectrum. This is about EM waves. These are the important chapters from class 11 and class 12, and also subtopics. You have to note down like this all the important topics from all the three subjects, and go through this short notes, formulas, and concept. Those who are attempting the mains exam on 28th and 29th, along with the short notes, and also have to practice PYQs. So if any PYQ is not getting the answer, any difficulty, and see the solution of that one, and learn what how the concepts are applied. This is very, very important. Don't panic. Everyone can get more than 60% of the marks if you are thorough in formulas and concept. At least for the students, those who are attempting 22, you have to complete at least two times. The students on 24th, 28th, 29th, you have to finish at least three times all the formula and concepts of all the chapters of three subject: maths, physics, chemistry. Okay, students, all the best.